Alright, here we go. Hello everybody. This is Thomas's Lab, episode 11. Let me just catch you up where I've been on for the past 9 years. Yeah, that's right, I haven't made a Thomas's Lab video for 9 years. The last one was in May 2011.
Hey guys, this is Thomas again. Thomas's Lab, episode 7.
The reason I wanted to restart this is because a few days ago I was looking at those videos, those 10 Thomas's Lab videos, realizing how far I've come. And they were short, sort of innocent videos. I was so young and I really didn't know what I was doing with electricity. Some of those things were pretty dangerous. I was like playing with live 120 volt AC. I didn't really know the dangers of it, but things have changed since then, and I was on a little bit of a hiatus from YouTube during high school, but now I'm in university. I'm studying engineering, so I'm having a lot more fun with electronics now, getting back into it. So yeah, I thought I would restart these short Thomas's Lab videos. So today I'm going to sort of show you my lab. This is a different lab, a different house. So I'll show you my new lab, and one of the topics today is going to be voltage multipliers. So I haven't really planned what I'm going to do, but just going to play around with voltage multipliers and hope you enjoy. So this is sort of the general work table. There's some instruments from the original lab, like this multimeter. It's a different glue gun. It's a different soldering iron. This is like an ancient soldering iron. Actually, it's more like a heirloom. It's my grandfather's. It's a little bit more organized than the last one, but I hesitate to say it's organized. There's just some miscellaneous parts in there. One of the new things I've been working with is Arduino chips, and if you don't know what an Arduino is, it's a programmable microcontroller. So you can, I guess, do more intelligent projects. And of course, with that, I have a bunch of breadboards. Flux, when I was back at the old lab, I never used flux before. A good friend of mine in my engineering program gave me a bunch of flux. He said, how can you ever solder without flux? So he gave me some flux, and I realized what a world of difference it was. I think most of these parts are from like computer boards and stuff, but I guess there's a bunch of LEDs, got some transistors, capacitors. I've been buying a lot of parts from Amazon, and so I bought this kit of a whole bunch of LEDs. I think it was only $20 for all this, and there's like something like 600 piece LED kit, so that's really nice. I also got a bunch of these diodes, so those are helpful for rectifying AC voltage and stopping stuff like that. Also bought this kit of capacitors. So as you can see, this one is all missing. It's because they're all on there. That's for later today. I also got these little, I forgot what you call them, but like helping hands or whatever. But they're really helpful for soldering stuff. And I never used to solder with ventilation, and this isn't quite what you would call ventilation, but it's better than nothing. So I have a whole bunch of boxes of stuff under the desk as well. Let's see what's in here. Oh, I forgot to mention, this is a bunch of resistors. It's also from the old lab. This is a Arduino thingy. It is a ultrasonic sensor. Yeah, this is one outside of the package. Ultrasonic sensor. A while ago, I went on a shopping spree of these Arduinos. So I have 3 of these and a fourth one over there. These are LCD screens. I have one on a project upstairs, and I have 2 here, but they're programmable with the Arduinos. I won't take these out, but these are gyroscope. I think it's the MPU 6050 gyroscope and accelerometer. Hopefully we can use that for a drone project that's coming up. I also got these water pumps for a planting project that I'm working on. It's upstairs. That's also for another video. I also have a bunch of transformers. These are from old devices. This is a huge one. One of the coolest additions is probably this 3D printer, the Anycubic i3 Mega. So I've had it for about almost a year, and it's treated me pretty well. I do have some stuff 3D printed. This is actually from a drone project that is in another video, but I am trying to manufacture and design my own propellers for a drone. And so I'm trying to figure out the optimum propeller design, and as you can imagine, that's quite a challenge, but trying different configurations and blade types. But yeah, the 3D printer comes in really handy. It's a real game changer. Alright, and on to today's topic. This is what you call a voltage multiplier. Now you have to feed this AC voltage, and what it does is it converts it to DC, and it also multiplies the voltage. So I actually just made this a few days ago. I've never made one before. Pretty much you charge up all these capacitors and they act like batteries, and then they're connected in series. So if you connect this capacitor to, or this end to this end, it's the combined voltage of all of these capacitors. So I think this one goes up to 140. Now let's have some fun with it. Yeah, so one note about this setup is I'm not actually feeding, as you might think, the AC voltage from the wall. That's 120 volts, and I'm just not willing to risk my life with that kind of voltage yet. So I bought this AC to AC adapter from Valley Village, $4. So it converts with, I guess, a transformer inside, converts from 120 volt AC to 6 volt AC. Now 6 volt is a lot safer to work with, and so plug that into my wall here. This little lead here is connected to the opposite end, so I get the combined voltage. Maybe we should run a test. Let's see what the voltage across all of these is. Actually, beginning with AC, let's go right into the supply, and that's 7.3, and I think this is the last one here, the maximum, so 142. So there's a combined DC voltage of 142 volts. Anyway, let's discharge this. This will be fun. Alright, so I have my setup here. I have my discharging thing, and once this makes contact, you should see a spark and a loud bang. Ooh, that was a nice one. Let's do it again. Ooh, that was a good one too. Maybe one more, just for the sake of the video. That one wasn't as loud. So I had a neat idea of visually displaying how much charge is in these capacitors. Now what I did here is, this last capacitor is I connected a LED, blue LED light to it, and a couple of resistors. Now the voltage across each of these capacitors individually is 18 volts. So obviously you can't directly just put a LED into 18 volts, otherwise it's just gonna burn out, because they require 3 volts. So I put a couple of resistors in series. Anyway, I'll plug this power supply in, and as soon as this capacitor charges up, this light should go on. And the thing is, this one charges last because the voltage goes back and forth between all of these first. So let's watch that process. It probably was pretty fast. Now once I discharge this, all the discharge is going to short circuit between here and here. That's what the bright spark is. So once that spark goes, the blue LED should go off, and then within a few seconds, because it's still, this whole thing is still plugged into the power supply, the capacitor should recharge. So let's try that. Oh yeah, there we go. So yeah, didn't take too long. Interesting. I think it's weaker because some of that charge is being diverted to the LED. So this pop you're hearing isn't as loud and isn't as bright. Well, thank you all for watching me on this return to Thomas's lab. I hope you enjoyed, and until next time.